After the colossal explosion of the Big Bang, when the first stars were beginning to ignite and the earliest galaxies were coalescing from clouds of gas and dust, humanity's knowledge of that era remained buried beneath billions of years of cosmic evolution. For decades, scientists dreamt of a telescope so powerful that it could peer into the earliest epochs of the universe, unveiling the ancient secrets of creation itself. That dream eventually took shape after 25 years of relentless research, collaboration, engineering, and innovation. And now, the James Webb Space Telescope, humanity's most advanced eye on the cosmos, stands as a beacon of discovery, illuminating the most mysterious corners of the universe. Unlike any observatory before it, the James Webb Space Telescope, or JWST, is designed not to simply photograph stars or galaxies but to travel backward in time, capturing light that began its journey billions of years ago. Operating primarily in the infrared spectrum, Webb can detect light that has been stretched over eons as the universe expanded. This feature allows it to see objects that are so distant, their light has been redshifted into the infrared. While Hubble observed the cosmos in visible and ultraviolet light, Webb's infrared capabilities let it penetrate dust clouds and reach further into the depths of time and space. Upon its launch, scientists around the world watched with anticipation. The telescope unfolded itself in space with near-perfect precision. Its golden hexagonal mirrors formed a massive light-collecting surface, and its delicate sunshield protected its sensitive instruments from the heat of the sun. Once fully operational, Webb began sending back data that instantly sparked amazement and confusion among astrophysicists. One of its first deep-field images focused on a seemingly dark, empty section of the sky. But once processed, the image revealed something astonishing. Thousands of galaxies, some of them formed just a few 100 million years after the Big Bang. What baffled scientists most was not merely their existence, but their complexity. Conventional wisdom suggested that galaxies from that era should be small, irregular, and slowly forming. Instead, Webb found galaxies that were well-structured, with spiral arms and defined shapes, resembling galaxies we typically associate with much later stages of cosmic evolution. This forced researchers to ask an unsettling question. Were our models of the early universe fundamentally flawed? Previously, it was believed that it would take billions of years for galaxies to develop such order and mass. These newly observed galaxies were already massive, some even rivaling our Milky Way in size, despite existing during a time when the universe was less than 5% of its current age. Their brightness and density indicated that star formation was occurring at a rapid, possibly uncontrollable rate. Even more intriguing was the presence of heavier elements, what scientists call metals, within these young galaxies. Elements like oxygen, carbon, and iron usually take generations of star births and deaths to accumulate. Their early appearance in such abundance points to an unknown, possibly accelerated process of stellar evolution. Adding to the mystery, Webb began detecting what appeared to be supermassive black holes within some of these early galaxies. Current theories struggle to explain how such enormous objects could have formed so soon after the Big Bang. Black holes grow by consuming gas, dust, stars, and sometimes merging with other black holes, a process thought to take billions of years. But if these black holes already existed just 400 or 500 million years into the universe's life, the timeline of black hole formation may require dramatic revision. Could there be mechanisms we don't yet understand? Perhaps black holes formed directly from collapsing gas clouds without first forming stars. Or maybe there are exotic forms of matter or energy that catalyzed their growth. Whatever the answer, it challenges the framework of modern cosmology. Some researchers have even floated bold and controversial ideas. A few theorists propose that what Webb is observing may not fit within the current Big Bang narrative at all. Instead, these anomalies might suggest the existence of a cyclic universe, one that expands and contracts in endless loops. Others speculate about a multiverse, where different cosmic regions follow their own unique physical laws. While these ideas are far from proven, Webb's data has undoubtedly reopened doors that many had considered closed. The nature of time, matter, and the universe itself is once again a hotbed of scientific debate. The implications don't stop with galaxies and black holes. The James Webb Space Telescope has also been peering into planetary systems far beyond our own. With its sensitive spectroscopic instruments, it can detect the composition of exoplanet atmospheres. In some cases, it has already identified water vapor, carbon dioxide, and methane, key markers that hint at the possibility of life. Webb has observed super-Earths, gas giants, and rocky planets in habitable zones orbiting distant stars. In one instance, it found the presence of silicate clouds, essentially sand, in the atmosphere of a distant exoplanet, painting a picture of alien worlds with weather systems we can barely imagine. What makes this even more exciting is that these findings are just the beginning. As Webb continues its journey, its observations will extend beyond individual planets to full planetary systems, helping us understand how solar systems form and evolve. It might also provide insights into our own cosmic origins, why Earth formed where it did, why life arose here, and whether similar conditions might exist elsewhere. Beyond planets and galaxies, Webb has also begun to explore the vast, mysterious filaments of gas that stretch between galactic clusters, the cosmic web. This intergalactic medium acts like the scaffolding of the universe, guiding the formation of galaxies and influencing their behavior. With its infrared vision, Webb can reveal the faint glow of hydrogen gas that permeates the space between galaxies, helping us map the invisible structure of the cosmos. And yet, for every answer Webb provides, a dozen more questions emerge. Why do some galaxies seem to form stars so rapidly, while others remain dormant? Why are there so many massive black holes in the early universe? What is the nature of dark matter and dark energy, those invisible forces that make up most of the universe's mass and drive its expansion? With every new image and dataset, Webb chips away at these colossal mysteries. Scientists are now working around the clock, analyzing terabytes of data pouring in from the telescope. Entire theories are being re-examined. New computer simulations are being run to try and replicate what Webb has observed. And amid the flurry of activity, one thing is clear. We are living in a new golden age of astronomy. The James Webb Space Telescope is more than just a marvel of technology. It is a time machine, a cosmic archaeologist, and a visionary tool that may one day help answer some of the oldest and deepest questions ever asked by humankind. Where did we come from? How did the universe begin? And are we alone? The discoveries made so far are a mere hint of what lies ahead. As Webb continues to peer into the unknown, it's likely that more surprises await, some that may confirm long-held theories, and others that will force us to abandon them entirely. It reminds us that science is not static, it is a living, evolving journey. Every answer is a doorway to another question. In the coming years, the James Webb Space Telescope may redefine our place in the universe. Its golden mirrors reflect not just ancient starlight, but also the unquenchable human desire to explore, understand, and wonder. Through it, we are reaching back across billions of years, and perhaps, just perhaps, discovering the very threads of our own beginnings. This is not just a new chapter in astronomy. This is a whole new book, and it's only just been opened.